Mathematics, Chapter 7, Section 3, Applications of Linear Programming. This section is full of practical applications of what we learned in the previous section. Our constraints are not going to be spelled out. Our objective function is not going to be spelled out. Instead, we have to get that from the problems themselves. The easiest way to do this is to make a chart, and you'll see how we do that as we go through this first example. So we have an office manager that needs to purchase new filing cabinets. He knows that ACE cabinets cost $40 each and require 6 square feet of floor space and hold 8 cubic feet of files. On the other hand, each Excello cabinet costs $80, requires 8 square feet of floor space, and holds 12 cubic feet. His budget permits him to spend no more than $560, and the office has room for no more than 72 square feet of cabinets. He desires the greatest storage capacity within the limitations imposed by funds and space. How many of each type of cabinet should he buy? That last sentence gives us a good idea as to what our objective functions and our constraints will be. Our objective function is going to be the one that maximizes storage capacity. Our constraints are going to be floor space and funding. So the first thing we're going to do is make a chart. And this is a good practice to get into when you're dealing with these problems. We're going to represent the number of ACE cabinets by X and Excello by Y. We also noted the cost, the space required, and the storage capacity of each, along with the maximum availability for our money and our space. We want to maximize storage capacity. So 8X, which is our capacity from the number of ACE cabinets we buy, plus 12Y, the amount of storage from the Excello cabinets we buy, that's going to equal Z, and that's what we want to maximize. We do have two constraints. Our budget, we can only spend $560, no more. So the cost of ACE cabinets, 40X, plus the cost of Excello cabinets, 80Y, has to be less than or equal to $560. We're also limited by space. So 6X plus 8Y must be less than or equal to $72. It kind of goes without saying, but we also have the additional constraints that X and Y must both be positive. And we do what we did in the last section. We graph it. So here's our lines graphed. We have kind of a almost triangular region. We find our corner points, and those are 0, 0, 0, 7, 8, 3, and 12, 0. We put those X and Y values each into the objective function, and we, again, remember we want to maximize our storage space, and we get a maximum storage space at 100 cubic feet, and that happens when we buy 8 ACE cabinets and 3 Excello cabinets. Now you try this problem. Do just what we did, create yourself a chart, find your objective function and your constraints, and then do just what we did in the previous section. Pause the recording, give this a try, and resume the recording to check your answer. Okay, first we create our chart. Food A, the number of units of food A will be represented by an X, and the number of units for food B by Y. Then we have our grams of protein and grams of fat and the cost. We have a minimum requirement of 30 grams of protein and 20 grams of fat. Now we're going to use this to develop our objective function and our constraint. We graph it, moving around. We find our corner points, and putting those values into our objective function, we discover that we have a minimum value of Z when X is 3 and Y is 4. So 3 units of food A and 4 units of food B will give us a minimum cost of $1.02 per serving. Here's another example to try. This time it's a financial problem. Make you aware of a term used here. You've probably heard the term standard deviation before. For stocks in particular, the standard deviation is an indicator of the risk involved in an investment. The higher that number, the greater the risk. And the idea is to maximize your profit but minimize your risk. Read the problem and pause the recording, give it a try, resume the recording to see how you did. Okay, here's our chart. We have our shares of Costco, that would be X, the number of shares of CVS, Y, cost, profit, and risk. And we need to keep our cost at or lower than 5,000, and we want our profit to be at or greater than 800. Okay, we also have the constraint that X and Y have to be greater than 0. Our objective function to be minimized is the amount of risk. So we have our equation. Our objective function is going to be Z equals 15.9x plus 19.5y. Okay, here's a summary of the information we just collected. There is a graph of our feasible points, very narrow triangular graph. But the important thing is to find those corner points and then put them into a table. Put those points into our objective function, and we find that we have a minimum of 1,367.76. That occurs at 14.4, 58.4. Now she has to buy a whole share of stock. She can't buy just a fraction of one, so she should buy 14 shares of Costco and 58 of CVS. Right, here are some practice problems. Give them a try. There are not very many of them. Check your work. Pause the recording while you're trying it. Resume the recording to check your answer. Do that for the remainder of the video.